Okay, this video is for my pre-calculus class where we're doing some word problems for the law of sines and cosines. So this is lab 2. I'm going to go through and make videos, hopefully of each one of these. So I'm going to try to do a couple problems per video so that there wouldn't be so many. So this first one is Angie and John follow a familiar triangular path when they take a walk. They walk from home for 0.52 miles along a straight road, turn at an angle of 95 degrees, walk for another 0.46 mile, then return home. Find to the nearest tenth of a mile the length of the portion of their walk. Well, like I always say when I do these, so I'm going to make this green, so hopefully they have a nice walk on green grass, is that drawing the picture. So they walk from home for 0.52 miles along a straight road. So I just kind of drew this because I know eventually I'm going to do a triangle. And then, okay, so here's and then they turn at 95 degrees. So a right angle would kind of go like this. So I'm going to kind of make it more like this. And then here's my triangle. So here is, they turn at 95 degrees. So here's my 95 degrees. Now remember, my triangle might not look as good as what I'm putting here. So they're walking 0.52 miles from home, and then they turn and they walk another 0.46. I actually could move both of these because this is actually, let's do that because this looks weird because that's longer. Okay, so I have 0.52 miles here, and they turn. So this is their home. We'll call this home. They're leaving home, walking 0.52 miles, turn 95 degrees, go 0.42 miles. So these are in miles, okay? And walk for another 0.46 miles and then return home. It says find to the nearest tenth of a mile the length of the last portion. Okay, so they do here, they turn, okay, and they go back home. So we're looking for this last part right here. So if you wanna, you can call it ABC. So let's do A, B, C. And here's little a, here's little b, little c, okay? So I look at what I can do, and it looks like for me to find that, I'm going to have to use the law of cosines because I only have one angle. So I'm going to use the pattern b squared equals a squared plus c squared minus 2ac cosine of angle B, which is 95 degrees. I'm just going to throw that right in. And this looks like one of the ones where I can just throw everything in. So I have b squared equals 0.52 squared plus 0.45 squared minus 2 times 0.52 times 0.45 cosine, I'm kind of running out of room here, 95 degrees. So look, everything is there. So I'm going to throw it right in my calculator. So I get b squared comes out to be 0.52395. So b is 0.7 miles. So boy, my picture really doesn't look like that because b looks like the longest side. So that's what comes out for the last part. Now it says find to the nearest tenth of a mile the total distance they walk. So I'm just going to add all three. So I got 0.52 plus 0.46 plus 0.7 is 1.68. And they said to the nearest tenth, so they walked about 1.7 miles. So sometimes your picture, the lengths won't look the same, but at least it's helpful if you draw them and you can do the work. All right, that's number one. Let's try number two. A pole is braced by two wires that extend from the top of the pole to the ground. The lengths of the wire are 16 and 18 feet, and the measure of the angle between the wires is 100 degrees. Find to the nearest foot the distance between the points on which the wires are fastened to the ground. So again, this is kind of hard to draw because you're like, well, where are the wires? Are they on the same side or opposite side? If I don't say the same side, so I'm going to call this the pole, right? Here's my pole. So I have a wire here. So here's my pole. I'm just going to draw a little pole here. And I have a wire over here. And there's the ground. Okay. So you're like, how did you know to do that? Well, I didn't say the same side. So here's my pole. Okay. And here's one wire. And here's the other wire. And I kind of called this one was 16 feet. I'll put this one here. It looks a little shorter. Again, my pictures don't always match, but it's nice to look at it. And then this one here was 18 feet. And I keep touching this, so there's like marks all over the place. Drives me crazy. The other thing they told us that it was 100 degrees between the poles. So right here, my angle here is 100 degrees. Between the wires, excuse me, not between the poles, but between the wires. So what do they want to know? Find to the nearest degree the distance between the points at which the wires are fastened to the ground. So here it's fastened to the ground and fastened to the ground. So I'm basically looking for this. So if I were going to label this, I always kind of tell everybody, just do ABC or whatever makes you good. So I have a little B here, I have a little A here, and I have a little C here. It just helps you doing the pattern. Again, I don't know what the distance is, and I only have one angle, so I can't use law of sines, so I'm going to use law of cosines. So I'm going to do b squared is the other two sides squared. So I have 16 squared plus 18 squared minus 2 times 16 times 18 cosine of 100 degrees. So part of this, when you do your quiz, is drawing the picture. So this is almost like you're looking above. The pole's like straight down and you're looking above. I go ahead and put all this in my calculator. And when I do, I get b squared. And you should practice this to make sure that you're getting a 680.02135. Then I take square root of both sides because I want to know what b is. And they said to the nearest foot, so it comes out to be 26 feet. So that's what b is. Distance, okay? So that's 2. Let's see if we can get one more. Let's do number 3. Okay, so it says 2 points A and B are on a shoreline of Lake George. So I'm going to do, here's my shoreline. So I'm just going to go like this. So I have points A and B are on the shoreline. So let's say A is here, B is here. Okay, so A and B are on the shoreline at Lake George. Okay, a surveyor is located at a third point C, some distance from both points. Okay, so they said the distance from A to C is 180 meters and the distance from B to C is 120. So this is going to be a little bit longer than this, and this is a little bit shorter. So there's scaling. So here's my point C. So here's my surveyor. So let's label everything here. So this was 180 meters. This was 120 meters. They already have A, B, and C, so that makes it nice. And this right here is Lake George. I hope you notice this is Lake George right here. Now I want to know, the surveyor determines the measure of angle ACB is 56.3. So ACB, so it's going to be right here, is 56.3 degrees. Okay. Now they want to know, basically, to the nearest tenth of the meter, what is the distance from A to B? So they want to know this distance from along the shoreline, which is a little c. So let's set it up. I got c squared are the other two sides squared. So I got 120 squared plus 180 squared. All of these are law of cosines. Pretty cool. Minus 2 times 120 times 180 cosine of 56.3 degrees. Again, everything's filled in. So I have c squared comes out to be, ooh, this is a big number, 22,830.72073. I hope you realize I'm not rounding. That's what's on the calculator. So then you can take a square root while it's on your calculator. And they want it to the nearest tenth, so I did 151.1 meters. So that's what it is across the shoreline. So this is 151.1 meters. Okay. So I'm going to do another video with other ones, but that's the first 3 of this lab. I hope this helps.